Hi everyone. So today what we're going to do is look at a little bit more at a practical use of the dot product. We're going to get our other character doing some stuff because right now, if we take a look at it, pretty basic, just kind of stands there, doesn't react to the character. I mean, we can shoot it because it has all of our base character's functionality on it, but we don't have anything really controlling it or telling it what to do, so it can be a little bit more reactive in the level. So before we get into that, I want to just remind you guys a little bit about the content examples project. And in here, there's a bunch of different levels. Right now I have it filtered for the math hall. Math has a lot of good math functions. One of the things we'll be using today is going to be that dot product. So the dot product is comparing this yellow vector with this red vector right here, and basically how close they're pointing in the same direction. And we can actually adjust how close they are and see what dot product value we can expect. So we're actually getting pretty much 0 when it's almost perpendicular. And if we get it close to about the same or parallel, we'll get 1. If we go the opposite direction, we'll notice it's a -1. So this can be really useful comparing objects' directions to figure out, are you in front of, are you behind another character, things like that. So what we'll actually be doing in our level is getting our AI to track our character and determine if it's in front, and if it's within a certain range, we'll actually tell it to shoot and stuff, just to get a basic turret kind of functionality. So we're in our normal level. What we're going to do is open up our base character. And the first thing I want to do is add a new component, because we need to determine if a player is within a certain range. So we can add a new collision component. We'll just go with a sphere collision. And we'll actually rename this sphere to aggro range. And what we want to do is go to our collision settings. We do want it to overlap everything. What we'll actually do is change it to no collision at first. Then we'll go to custom just to set up some defaults to play around with. We do want query only. We don't want any physics reaction. We just want to see if the player is inside this trigger or not. For object type, we can go ahead and go with dynamic. And then down here, we can ignore the traces so that when we're actually aiming, it'll get ignored. And for our object response, we only want it to overlap on pawn. For everything else, we'll go ahead and set to ignore, because we only care about characters if they're inside this aggro range. Okay. We're going to go over to our viewport to make sure that the sphere is a good range. Right now, our player would have to be inside that sphere, which is actually impossible because they can't go inside the capsule around it. So we'll also need to change the radius of that sphere. So from 32, let's bump this out quite a bit. Let's go 600. And this gives us a big range around our character that if another character enters it, it'll actually trigger an overlap event. What we can do from here is with this sphere collision still selected, we want to say what happens when something begins overlapping. And that dropped an event on our event graph. And I have a lot of tabs open. I'm going to close those out so it won't cause any issue. So on component begin overlap for our aggro range, we can check that other actor and actually start tracking it. We can promote this other actor to a variable. We can then give it a quick name. This will be our target actor. So the one that we're going to try and track and shoot at once we're at a certain angle and stuff. What I'm going to also do is go ahead and add a print string to see if this is running. I'm going to just print out the other actor's name so we know what object we've started tracking. Compile, save. I'm going to just dock the tab real quick. And back into our level. Since we did this on base character, it should start working on all of these. I'm going to move them away a little bit so we can see us walk into that area. We can play. I'm going to make sure the output log's showing so I can see any messages that I might miss on screen. And we start walking over to it, and we see, boom, there were 4 prints. So base character sub 2 is hitting once, then on C0, then sub 2, then on C0. So we have this currently running for both of our characters. So both of our characters are now tracking our targets, essentially. Next thing we want to see is, does anybody know why we're getting 2 messages for each time it overlaps? And I could play it again just to show you that it is printing twice even though I hit it once. So you mentioned that the player character also has a radius. That explains why we're getting 2 different characters sending a message, but each character itself is saying it twice. The big reason is because our mesh is also generating overlap events, and our capsule is also generating overlap events. So you'll also have this problem when you're playing in Unity and you have a trigger set up. You may get multiple on-enters or things like that if you have multiple different collision components on it. So to prevent that, we're going to stop playing. What we can do before we just immediately set our target actor, we can actually check our target actor. If it is valid, and this is a similar process that we did for our door. So what we want to do is see if that actor is not valid before we go ahead and set, meaning, are we already tracking something, or have we not started tracking anything yet? So we'll compile and save. We'll go ahead and play. Now, Whoops. It's not running at all. What did I mess up? Target actor not valid. Should be good. Give me 1 second. I'm not sure why that was perfectly fine. Very interesting. So for some reason, it's not running that. Let's add a breakpoint and try and see what's going to happen. Stop, play. Ah, right. So immediately when we start playing, it's going in here and saying target actor, current is none, the other actor that's hitting us is base character 2. So right here, if we compare it to ourself, it's actually hitting its own components. So as soon as we begin playing, our aggro range is detecting, hey, there's a collision with this capsule component and a collision with the mesh from your own character without even running into it. So we need to add one more check. We also want to know if the other actor is not equal, and for this one, we'll just say ourself. Need to give myself a lot more room here. Go ahead and create a branch. So now when the other actor hitting us is not our own actor, we can then go check, did we set target actor yet? If not, we'll go through and set that. I'll remove the breakpoint, compile and save, and we can start playing around with this a bit more. So running through, we hit it once, and we're getting the message once for each object. One for our base character, or one for our player, and one for our enemy. Awesome. So we know we're actually setting that other actor in here, and we can start doing comparisons with it. So let's go ahead and find our event tick. So we can start adding some checks and prints and things like that just to figure out where our character is in relation to another. And actually, I don't necessarily want all of my characters doing this. I mean, it's kind of redundant to set up any AI on our player as well. So we'll just go ahead and leave this as is, just tracking the other character, but not doing any comparisons or figuring out what to do for that. And we're going to create a new child of this, so it inherits all that normal functionality, but we're going to add some additional functionality for our character enemy. We open that up. And I always forget to turn on inherited variables before I come in here and stuff like that. Compile on success. All right. So in here, we have a brand new graph that'll be specific to our AI or enemy. So in our tick, we can take a look at those different things. We're going to get a reference to our target actor. We'll get its location. And we'll compare that with our location. So does anybody remember how to get a vector pointing to this target actor while we're inside this graph? It does involve a subtraction, but what order would the subtraction go in? B minus A. Yep, you always want to your target from your source. So that if we have our target right there, we can just get our location and we can do a subtract. We want vector minus vector. And then we can go ahead and use this. We're given a vector pointing towards our target. We can compare that with our forward vector using the dot product. So to do that, we just go ahead and type dot, and we'll see from our vector, we can do a dot product. And then for our other one, instead of asking for our location, we'll give it our forward. So get actor forward vector. Before I do any checks with it, what I'm going to do is just add a print string so we can see what kind of values we're working with. And we'll just print out that value. And we're connecting this from tick. We want it to run every frame so we can see it update while the game's running. Compile, save. Need to remember to get rid of just our base character in the level, because we now have a specific enemy that we have running code. So we press play. I'm getting a negative 430 value. And then it started updating when I entered. If I stop playing, we're getting a lot of errors from that graph. So it says accessed none, similar to a null reference exception. Trying to read property target actor, meaning that target actor was not set and we were trying to access it. So we can see that's coming all the way from the print string. And I just clicked the link, brought me right to it. So this code right here, because it's not on an exec, it has to connect up to the latest exec that's actually running it in the chain. So target actor was accessed and it returned none. How we're accessing it? Well, we're asking it its location. So that's glitching everything out. What we want to do is make sure that our target actor is valid, because when we start the game, it's not set until we're inside that collision. So we'll check is valid. Plug that up and only do our dot product and check when it is set. Compile, save. So now when we go to play, we're not seeing any printout. And as we run in here, we're getting a value, but we see that's negative 61. So if I'm directly behind it, negative 240, even down to negative 60. When we were over here, it's still only negative 53. So this value is not what you guys have been showing for the dot product before. Remember, you typically expect a -1 to a +1 value from dot product. What we want to be working with, and I'll jump back to the dot product example. For normalized vectors, magnitude equals 1. So we just want to care about the normalized vector. So back to our thing, if we go ahead and check what vectors we're comparing, well, getActorForward returns a vector of length 1. Length and magnitude are the same thing, just FYI. So this one's normalized, but because these two actors can be a different distance apart, we want to basically get rid of that distance aspect and just care about the direction. So what we can do is normalize. All right. Now that we've normalized that, we can check our values again. Run in here, and we see as my character, doesn't matter which direction I'm looking, because we only care about what direction our other character's looking. If we go behind it, we see it's -1, and as long as I'm behind it, it's going to still stay negative values. So we know anything slightly in front is that positive. That's the same concept we were using for our doors to figure out if we want to open one way or the other. So now we see that the value gets pretty close to 1 when we're directly in front of it. I want a little bit of a range, so maybe 0.9. That looks like a good wide angle for that character to shoot. So we now know what values we want to work with. So in our enemy, instead of just printing a string, I'm going to break that and use this dot product value. We can check if it's greater than or equal to a float. Remember, we want it at a somewhat tight angle, so we'll go 0.9. And we'll branch off that. And next up, when this is true, we can go ahead and print a string. For the string output, we'll actually just change that to target is in front. And we'll replace that with a shoot in a few minutes. So we'll compile, save. And just want to make sure that that's hitting at a reasonable angle. So we'll double check our values again. Run inside it. It'll start tracking. As we approach the front, lets us know that that target's in front. And as soon as we get out of that front angle, it's going to stop letting us know that it's in front. So we've got the perfect trigger, kind of calling something that's just a print right now when we want this thing to shoot. Well, if we take a look at our base character of how we were telling it to shoot, in our input action for attack, all it's doing is telling it to play an animation. So I'm going to actually copy that, the AnimBP and play attack animation, and I'm going to drop that right in here. We're going to replace that print string with this. And we should be able to see our character shooting. So we'll play. Started tracking. And when we're pretty close, it's going to start shooting. Problem is, well, a couple of problems. It's not really shooting at me, and it's also just continuously shooting, never reloading. So definitely a couple of problems with that. If we take a look at our base character for how it was doing the on ready to fire, or basically where it's spawning the bullet, our base character is asking the HUD where the HUD's pointing, what the reticle's over and stuff. Problem is, our enemy doesn't really have a HUD. We only create one HUD for the player. So we are going to have to rework this a little bit. So in our character enemy, we can change or override the on ready to fire. First thing we'll do is go ahead and check for branch. Oh no, I want it is valid. I want to see if we have a target or not. Is valid. And go ahead and add that target actor, because we want it to do something different for when we have a target to shoot at or when we don't have a target and it was told to shoot. So when this is valid, we basically want it to shoot at our target actor. Well, this math right here is basically doing that for us. Just getting a vector towards our target. I'll just clean that up a little bit. And if we remember from our base character, the position we were shooting from was actually our socket location. So I still want it to spawn from the hand or from the tip of the gun, wherever we place that socket, towards the actual other character. So instead of just saying our location, we'll do it from our socket location. And I'm going to keep kind of going back here to grab a couple of things. We see we're just saying for the current weapon to shoot. Back to our enemy, I'm going to just paste that weapon shoot in. Our shoot location is going to be the same from our socket. For the rotation, well, we want it in this direction, the direction towards that target. And it can auto-convert it for us. We'll drop in that rotation from X vector. That's what we want to happen when it is valid. When it's not valid, we still want it to shoot. So drop in that other shoot node. Just paste it because I had already copied it from before. For our location, well, we still want to keep it from the socket. But our direction, we definitely don't want to do this subtraction. That's how we were getting the error message before, because our target wasn't actually set. So what we could do is, when there is no target, we'll just shoot in the same direction as our forward. Get actor forward. And that will be our rotation for our bullets. Compile, save. Go ahead and play again. Started tracking. Once we get mostly in front of it, we see that that bullet's actually going to arc between where our target is. Still got the problem that it just kind of runs out of bullets and keeps shooting. So let's go ahead and fix that next. So our enemy, right after we shoot, we could tell it to go ahead and do our reload if our bullets are empty. So we can check from our current weapon. We'll ask it get current ammo. We'll do a comparison. If that's greater than, well, let's do less than for the reload. We'll do less than or equal to 0. And we'll do a branch off that. We want this branch to run if either of these chutes run. That is one thing I saw quite a few people do. They had done the disable movement and they forgot to plug both the chutes in when they attempted it again and had to just copy and paste or something. One thing about branches, you can combine two outgoing branches into a new input. You can never split an output. So just a quick tip about code flow and simplifying things down rather than duplicating everything for the top and lower half. So when this is true, that means we are out of bullets and would want to reload. Well, let's jump back to our character. And we were telling this one to reload off our input action. You see we're playing the reload animation, and we have a little bit more info just to disable our character's movement. I'm going to leave that out for now and just grab the play animation. So we're just taking these same building blocks that we've created on our character, and we're just going to reuse it for our AI. All right. So got that compiled. Now we can test this out. Started tracking. And we've got it shooting. And it does reload. All right. So we do have a bit of a problem where I'm way outside of its attack radius, and it's still tracking my character. And even killed me. Alright. So we're also going to have to handle what happens when our player leaves that radius. We basically want to stop tracking our character. So in our base character, because that's where I did the collision for the other one, on our aggro range, we'll look at the other events. We'll do the end overlap. Just below that begin overlap. So for this, we'll go ahead and do a quick check. If the other actor leaving that radius is equal to the target actor that we started tracking, we will branch. And when that's true, what we can do is just set our target actor and we're going to go ahead and set that to nothing. Basically clears it out. Setting it to null sets to none, really. So it just clears out that variable if we don't plug anything in for a set node. We'll compile and test to make sure that it'll start tracking and then also stop tracking. So we're inside, it's shooting, and once we actually leave that radius, it stops shooting. Alright, so that's basically how you'd create a simple turret, but once again, this is a character, so it should really be running around the level and everything. So let's go ahead and give it some mobile, let's get it moving around. So to get things moving around, we need to let our character basically know about the environment a little bit. And for that, most modern engines use what is called a navigation mesh. So over in our modes, we're going to search for nav, and they called it just nav mesh in this one. We want the nav mesh bounds value. This basically describes an area that the player might be able to walk. And I'm going to just drop it down and then scale it up so it covers my entire playable level. So I'm going to bump the scale up quite a bit. I'm going to go 100, 100, and we'll go 100, why not, in the Z. So that actually creates a giant box around our play area. It's outlined in yellow, so it might be a little hard to see. But what that also does is if I click on this ground right here and tap P, P is the debug key to turn on the nav mesh rendering. You see it's filled basically anywhere this can walk with this green filling. It even goes up the ramp. And the reason why it's back around these edges a little bit and not right up to the object or inside the object, it does a quick calculation of, all right, well, how big is our nav agent or character's radius that it can walk it up to, and right there is about as far as it could actually walk. It couldn't actually go any further than that. So I'm going to just click on the ground and press P again to turn off the nav mesh view, because that can get pretty annoying just staring at that neon green for a while. And now that we have a nav mesh, we can tell our character to start walking around in it. So So we'll go to our character, or our enemy rather, because our enemy is the one with the AI stuff. We're just going to add a few things to begin play, just to kind of give this a simple wander behavior so it gets moving around in random directions and stuff. So there's some really useful nodes called AI move to. A couple of different options. We'll go AI move to. Use that one. We need to tell it what pawn we want to move. This is going to be ourself. We need to tell it a location to move to. So the way this task works, it allows you to specify a specific actor to move to or just a destination straight by hard coding a vector value. Well, we don't want a hard coded value. We want, oh man, I'm totally blanking on the name of it, but I'll try it. Random, oh, cool. Pops up right at the top for you. So from under our AI, navigation, get random point in navigable radius. So this is going to basically take a certain spot and a certain radius, and it'll auto-fill in the navigation information as long as you have a nav mesh in your level. So we'll say our origin will be, let's just go with our current location, so it can always update. And the radius we want to move about, let's go 500, just to get it moving. And what this is, you'll notice that it has a little clock face on the top right corner, very similar to the delay function, which means it's actually a pausing node. It can actually pause on this and then not run these other execs until after it's complete. So we'll get a success when it moves to the new spot, get fail if it for some reason failed to move to the new spot. And we also have a pass-through exec, just an exec without any name, which means it can start doing that stuff immediately. What we'll do is, on success, we'll go ahead and add a delay, and we'll have it wait around for 2 seconds. When that's completed, I want it to find a new spot and move to that. So instead of copying and pasting this a whole bunch of times over, I'm going to just drag it and loop it back. I am going to add a couple of reroute nodes to make that a bit easier to see. And we see it's going to run through that, wait for this to finish, wait for the delay to finish, and then start telling it to move again. So we've actually created an infinite loop in our begin play, so it'll just keep doing this behavior over and over. We can play again, and taking a look at our guy, we see that the enemy is now running around. So, a couple of issues. It's not going to really stop when the player's targeted or even chase the player or anything like that right now. But at least we got some movement, so he's not just a mindless drone or anything. If we wanted to add some player tracking and things like that, we would have to do a couple more checks instead of just immediately saying, once you're finished, sit around for 2 seconds, and then once you're finished with that, find a new spot to move to. We could do a check for, is the target valid or is it set? If so, maybe we want to move towards that target instead of repeating this same loop over and over. So a lot of really useful functionality from very simple nodes, just setting up that quick loop right there. And that's really only, 6 nodes total? 2 exec nodes and a couple of others just to get the random point and things. So we could easily just do a couple more branches and define its behavior based on different things. Once it's actually at those spots, or if it has a target, we could have it move towards the target instead. A lot of good functionality there that unfortunately couldn't actually fit into the class itself or test you guys on for this month. But anyways, that's about it for today. Hope you guys enjoyed a quick look at some of the AI for Unreal, and hope you guys continue to play around with Unreal as well as Unity and notice the similarities between them. There are definitely differences, but they're actually probably far less than you are expecting. So any last minute questions before I go ahead and log out?